Hello everyone, this is Mansa, she is Vaishnavi, he is Shravan. We are from CSE department. Now we are going to explain about AVL trees.
AVL tree. AVL tree is a height balanced binary search tree. Every node in an AVL tree maintains an extra information known as balancing factor. We need to check balancing factor for each and every node in the AVL tree. What is balancing factor? Balancing factor of a node in an AVL tree is difference between height of left subtree and that of height of right subtree. The value of balancing factor should always be -1, 0 or 1. If a new balance factor arises other than -1, 0 and 1, then we should adjust the AVL tree by applying suitable rotations. There are 4 types of rotations in an AVL tree: LL rotation, RR rotation, LR rotation and RL rotation.
So now we are going to insert the above elements by using AVL tree method. Here the first element is 9, which is nothing but the root node. Now check the balancing factor, that is nothing but height of the left subtree minus right subtree. Hence there is no nodes, so the balancing factor is 0. So the next element is 15. Now check whether the 15 is greater than the root node. It should insert at the right side. If it is less than the root node, then you should insert at the left side. So now check the balancing factor. The balancing factor for 15 is nothing but 0. Hence there is no nodes. And for balancing factor of 9 is 0 minus 1, that is -1. Left subtree minus right subtree. So the next element is 25, which is greater than the root node. So it should be inserted to the right side of the root node. And it is further greater than 15, so it should be inserted to the right of 15. Now check the balancing factor. So the balancing factor is 0, hence there are no nodes. Now check the balancing factor for 15. So balancing factor for 15 is left subtree minus right subtree, that is -1. Now the balancing factor for 9 is -2, which is not in the range. So now we have to apply the proper rotation. And now here the 15 becomes the root node and pull down 9 and 15 becomes the root node. Now this is how it looks. And now we have to insert the next element, which is 3, which is less than the root node. Now the root node is 15. Now check the balancing factor. Now the balancing factor for 3 is 0, hence there is no nodes. Now check the balancing factor for 9, which is 1 minus 0, that is equal to 1. Now balancing factor for 15 is 2 minus 1, it is 1. Now the balancing factor for 25 is 0, hence there are no nodes.
Now inserting 8. As 8 is less than 15, we should move to the left side. And it is further lesser than 9. So we should move further left, and it is greater than 3. So we have to place it right side of the 3. As here, 8 should be placed here. If we check balancing factor, for 8 it is 0. And for 3, it is 0 minus 1, which is -1. For 9, it is 2 minus 0, that is 2. Here the balancing factor goes out of the range. So we have to apply suitable rotations here. First we should take 3. 3 should pull down and 8 we should place it here. Like this, it is of LL insertion. Now 8 should go up and 9 should get down. After this rotation, we should place the same thing in the AVL tree. It will be like this. After placing the same thing, the AVL tree will look like this. Inserting 60. As 60 is greater than 15 and it is further greater than 25, we will place it totally right. Now checking the balancing factor, for 3 it is 0, as no node for this. And for 9 also 0. For 8 it is 1 minus 1, which is 0 again. For 15 it is 2 minus 2, which is 0 again. For 25 it is 0 minus 1, which is -1. And for 60 it is 0 because there are no nodes for the 60.
Insert element 55. First compare with the root node. 55 is greater than the root node, so check with the other element 25. It is greater than the element 25. Then check with the element 60. It is less than the 60. So insert the 55 element left of the 60. Insert element 55 to the left of the 60. After inserting 55, we should check the balancing factor for every node. Here for 55, the balancing factor is 0, as there is no nodes. For 60, the balancing factor is height of the left subtree is 1 and height of the right subtree is 0. So 1 minus 0 is equals to 1. For 25, the balancing factor is, here the height of the left subtree is 0. So 0 minus height of the right subtree is 2. 0 minus 2 is equals to -2. Here it is RL insertion, so we should take proper rotation. Now it is in the form of RL insertion. Now pull down 60 and it becomes the RR insertion. We should take left rotation. It is in RR insertion. Now apply left rotation. Pull down 25 and 55 becomes the root node. This is how it looks like. After insertion, this is how the AVL tree looks like. Now check the balancing factor for the AVL tree. Here the balancing factor is 0. For 9 it is 0. For 8 it is 0. For 15, 2 minus 2 it is 0. For 25 it is 0. For 60 it is 0. For 55 it is 0. Here we can see the balancing factor is in the range. Insert 95. First compare with the root node. 95 is greater than the root node. So check with the element 55. It is greater than the 55. So again check with the 60. It is greater than the 60. Now insert 95 at the right of the 60. After insertion, check the balancing factor for every node. Here it is 0. For 60 it is 0 minus 1. Minus 1. For 55, 1 minus 2, it is minus 1. For 15, 2 minus 3, minus 1. For 9, it is 0. For 3, it is 0. And for 8, it is 0. Here for 25, it is 0. Now we can see the balancing factor is in the range. Now insert element 1. It is inserted at the left of the root node. Now check the balancing factor for every node. Here it is 0. For 3, 1 minus 0, 1. For 8, 2 minus 1, 1. For 9, it is 0 as there are no nodes. For 95, it is 0. For 60, it is 0 minus 1, minus 1. For 55, it is 1 minus 2, minus 1. For 25, it is 0 as there are no nodes. For 50, 3 minus 3, 0. So here we can see the balancing factor is in the range. After inserting all the elements, this is how the AVL tree looks like. Thank you.